Hello, everyone. Welcome to our How to Become a Data Scientist webinar. My name is Laura Gibson. I am the host of today's webinar. I am the content lead for QuickStart Inc., IT career readiness company. And our guest speaker today is Shane McCallum, who is a data scientist. Could you tell everyone a little bit about your background and just introduce yourself?
Sure thing. So my background is actually in law enforcement. I originally went to college for sociology, focused in law enforcement. But eventually I just kind of found my way down the path of looking into data science and data analytics. And here I am now, absolutely in love with it as a career and looking forward to a lifetime of growth and development in it.
Awesome. So why don't we get started? What inspired you to consider data science over other IT fields?
Yeah, so I've always been someone who was pretty analytically minded, and that's definitely one of the number one skills I would say is needed for working with data. Like I mentioned, I was originally in law enforcement, and I always wanted to be a detective and kind of solve mysteries and solve kind of problems and such. I knew that that would be a rewarding career for critical thinking and feeling like I was actually solving real world problems. But I discovered shortly after getting started in it that it's probably going to take me anywhere from 5 to 10 years before I got to really be a detective and work in investigations. And that was just kind of too long for me. I've never been really one to want to wait that long for anything. So while I was browsing around for federal positions like the FBI, I saw that they were really seeking out people who had backgrounds as, data analytics or someone who had worked with machine learning or data analysis. Mm-hmm. And I started browsing a couple of these boot camp programs, and I spoke to a couple friends who really recommended some. And as I was looking into them, Springboard was just the right choice. Very much dedicated to a self-paced program. Mm-hmm. And once I started the prep course, I didn't know anything at all about data science or coding prior to that. I realized it was very much scratching that itch of problem solving, critical thinking. And I could really see how you have an impact on the world around you when you are working on these kind of projects. Mm-hmm. And so now here I am, and I really enjoy the fact that every day I have to critically assess a problem. I have to, try to develop a solution for sometimes a problem that might not have one really. Mm-hmm. And all this, I think, is kind of truly filling in for that desire to do detective work, because mm-hmm. really when you're working with data, you are being a detective. So yeah, and that's kind of how I kind of fell into it now.
Yeah, I love that you said that, working with data is kind of like being a detective, and you mentioned that, you thought you could really make like this real world impact with data science. Could you talk about that more? Like how, is data kind of like being like a detective, or what kind of impact do you feel data has on our world?
Sure. Yeah. So most of the problems that I've encountered, at least in data science, really aren't that technical. You're really kind of being approached by a company who has a problem that they see as, hey, we're having trouble targeting our customers. We want to narrow our targeting for specific marketing to a customer, and that really on the surface level might not seem like it has that much to do with investigations, but when you're a data scientist and you start reading the data, you kind of start figuring out who your detective is. Sorry, not who your detective, who your customer is. And you start realizing there's these patterns among them that really kind of start putting them into categories. And mm-hmm. as you're doing this, you're starting to learn more about them, and you start kind of, oddly enough, almost making predictions in your mind before your model's even finished. And with that, it's all of this very similar to almost the same kind of approach that you see actually on shows like, Criminal Minds or something like that, where
Gotta
they're
stay
trying
one step ahead.
and they're trying to build this image of, the suspect before they even have seen, like they haven't even seen them yet. And it's very similar in data science that, your suspect is almost always going to be that model that you're chasing. And you're going to start catching kind of drifts of, what it's going to need to require to kind of solve the problem. And sometimes you're wrong the first time. You get really far in the investigation and you're like, oh, well, it's not really having the performance and resolving the problems like I expected. Let's look at this approach. And that's, I think, just, the absolute joy of it is you do really get to kind of be almost a snoop. You go through, someone's entrusted you with a lot of private data, and you get to kind of go through it and make this, miracle kind of come out of it. And it's often kind of like nailing a suspect.
So it sounds like not only would, the analytical mind be a great strength in this, but also a creative mind as well, to be able to go back, to the drawing board or think of a creative solution for this, suspect that they're trying to catch.
Definitely.
All right, awesome. What does the career field look like for those aspiring to enter the data science field? Like, do you think data science is a competitive job market? Do you think it's in high in demand?
Yeah, so honestly, data science is in a very interesting spot right now. And maybe I'm just too young or inexperienced to really compare it to something else that has kind of had a similar growth within it, but it's almost that data science is now about to break into being more of a trade. That and data analytics, data engineering, machine learning, because those who are within the job field see the need right now. They see just how many vacancies there are. Data scientists right now are, think of how when your electricity's out, maybe the wire in your house isn't working, you call an electrician, but you don't call a plumber who, if you really need them to, they can be an electrician. And that's kind of what data science is right now, is that a lot of companies have the need for data engineering before they even have the need for data science. And they're kind of hiring a data scientist to do it because it's part of what we do. And there's this massive market full of openings right now where companies they're becoming so focused on their data and realizing the value it has to them, realizing that, really there's a great way of having a return of investment if you just use your data and have someone who knows how to use it, working to kind of develop more of your customer orientation side, or even streamlining perhaps a development process within the company. And so there is a huge vacuum of positions right now where, I would say, honestly, in the U.S. alone, there's probably somewhere in the neighborhood, from what I understand, about 200,000 openings for data science or data-related jobs. That said, though, there's a huge disconnect between these companies and the reality of someone who's qualified to do the job. Because many people are going to find that when you speak to someone who's a data scientist, even at the senior level, senior data scientists at these high companies such as Nordstrom, T-Mobile, Amazon, they're going to tell you, you do not need a master's degree or PhD to do this job. There's a lot of entry-level jobs that you're going to see, and it says they want someone with a master's degree and 3 to 5 years of experience. And you talk to anyone who works in data science, they're going to say, no, you don't need that. You do not need that to do that job. And so this kind of, difference between like what really is needed to do the position and do it well, and that kind of having not caught up with hiring managers and talent acquisition managers, those people are doing a really good job and they're doing a hard job, and, they kind of see what is required to do maybe other entry-level jobs in similar fields. And I don't think they've really caught on that there's a lot of people doing, anywhere from a 6 to 1 year long program that really takes them through data science and what's needed. And that those people are totally ready to knock this kind of roll out of the park. So that's really the biggest kind of issue facing careers in data science right now is that there's such a demand for them and such a need, but there's a lack of understanding from companies right now within their, kind of hiring departments of who can actually fill that need.
Right, and earlier you mentioned there's more of a demand with like data engineers or like data scientists. Could you kind of talk about like the differences between those two roles?
Sure, definitely. So there's a lot of companies right now that are realizing they have, somewhere in the neighborhood of thousands of terabytes of data that they've been collecting since, 2002 about their customer database. And they want to kind of immediately have, what I would say, they describe it, they want Skynet running everything. And, they want an AI like the Terminator, kind of doing everything for their company and running their business. And the truth is what they need is a data engineer. And a data engineer is someone who's almost entirely doing the front end of data science, where they're taking this data, which is often called in data science a data lake, where it's absolutely unorganized. You could, put a bucket in it, and when you pull the water, like look inside, there's just no organization of data. It's a lot of, a little bit of everything. And so as a data engineer, you're kind of taking that data lake, and for those of you probably familiar, you're using what we call the term ETL, where you're extracting that data, you're transforming it into something that's pretty, I would say, legible, and actually, something that you can reference reliably. And then you're pulling it into what we call these data warehouses. And once it's in that data warehouse, that's where we kind of see things like SQL being used and being able to reference that data and be, pulling it up pretty quickly. And it's, on the demand of anyone who is in the company that they can access it. But that's pretty much where the data engineering stops. It's almost always kind of just setting up that process, which is actually probably about, I would argue, 25% of the actual jobs right now for data science are probably going to be listed as a data scientist, but what they really mean is they need a data engineer. And then like the other 10% of the time, you'll do what a data scientist does and go through the whole method of, extracting data, cleaning it, exploring it, developing a model, testing it, and then actually running it and putting it into production.
Yeah. Speaking of, job duties, could you give us like a typical day for a data scientist, or a typical like long project, short project, those sort of things?
Sure, definitely. I would say that it's definitely going to vary quite a bit. And so with my program Springboard, I've interviewed somewhere in the neighborhood of about 40 data scientists now, all from entry level to senior level. And with that, I've noticed there's some similarities, but a lot of times it's pretty dependent on what the company needs at the time. But overall, a pretty good broad stroke of what it looks like daily is that you're going to come into work, you're going to sit down, and you're going to open up whatever is the host for most of your code and what you're working on. A lot of times that's going to look like a GitHub repository. And within that GitHub repository, it's probably all going to be private and secured. You can try to be making sure you're not letting anyone have any access to, some pretty secret information that this company is entrusting you to work on. Sometimes it's not going to be like something like that. Sometimes it'd be like a hosted cloud platform where you'd be working on the data and not have something at all really posted anywhere online. It'd all be inside the company. And with that, it's kind of almost, I would say, probably the first 10% of the day, your first couple hours is actually going to be keeping up with what has been going on overnight, maybe since you last left the model, if it is still running, because you'll have models where you're working on them, you click them to run, and it's the end of the day, and all right, we'll see how far it gets tomorrow, before we'll see if this thing actually works. And then you kind of come in tomorrow and you realize, all right, here's all the errors that the code's telling me. Let's go take a look at the bugs. And so that could easily be anywhere from the first, I would say, in an average 8-hour day, 1 to 2 hours. And then after that, you're going to start, again, approaching kind of your timeline and looking at, whether you're working on a team or by yourself, this timeline of the model and what you want it to do and at least what you're trying to get done today. And really just start kind of working away on that. Again, a lot of that is going to be, refinement and tuning the, aspects of the model where, a lot of it's probably going to be that path of, ETL, extract, transform, load from the data lake to the data warehouse where, oh, something went wrong in our pipeline. All of a sudden, everything we're getting from, this part of our data warehouse is just, garbled. We have no idea, absolutely disorganized. And then, maybe about, I would say, one day out of a short-term project, 1 day or 2 days a month, you're actually spending all day writing this model, doing, linear regression, making sure that everything's going to work, and you're running through it and kind of running through a couple different, ideas of making sure that everything is kind of fine-tuned and you have your most valuable parameters set. Maybe you're realizing you need to run something such as XGBoost, which is another way of improving usually the recall of like a classification model. But with that, again, most of the day you're going to be spending on getting that data to be legible and usable in your actual model. And once you get that, you're probably going to spend about 10% actually developing the machine learning part of the project.
Could you go into more of like the machine learning aspect of this?
Say that again?
You mentioned there's an aspect of like machine learning with data science. Could you talk about like how those things are connected?
Yeah, so machine learning is honestly, the cool part. It's the part that all of us want to do. The idea of writing something that predicts the future is pretty awesome, and it's kind of why a lot of people get started. But the truth is that most businesses don't need us creating an incredibly advanced neural network that is really great at forecasting the financial market tomorrow. Most businesses have a need for probably linear or logistic regression for a model, or maybe just a simple classification model. But they don't need us to really invest in like these super complex models that we might have worked on in our education for being a data scientist. And with that, it's still enjoyable. You're still going to have fun writing these models that are going to be working on perhaps it is them predicting, you're trying to write a model that's going to predict how much it's going to cost to do maintenance work on a manufacturing product, like, manufacturing computer hardware. And that there's somewhere along this, production line where you're losing about 3% of your chips that, are for a certain product. And your model is basically going to be able to forecast the expenses of repairing that and how often you're going to have to repair that part of your production. And perhaps once you see that and you do the forecast, the company realizes like, well, that's going to be more expensive to fix than it is when we just have, 3% of these chips not working. And we might as well just take the loss in financial revenue of these chips and having to do a return on them than spend the $20 million it would cost to repair the production line. And there's a lot of things like that where basically you're using machine learning to help a model learn on about 80% of the data you have. You test it on the other 20%. If it's performing well, then you got a model that's pretty reliable. And then that model is just basically giving you a return of investment for the project. And that's what you kind of take to your stakeholders at the end of the day. One of my favorite ones is called recency, frequency, and monetary value. And for any of you, those of you who have a business analytics background or a business intelligence background, you're probably familiar with that. It's where you break up a company's customer base into tiers. And exactly that email you get saying, hey, you are being offered, X amount of discount or membership at this discounted rate. That's the company having broken you down to how valuable of a customer you are. And then some data scientist somewhere basically made a model that says, hey, if you send, perhaps these offers to the customers that are visiting your website X amount a week, and, spending X amount of dollars a month, we've seen that if you send this, this offer or discount to them, that they actually will probably become, your long-term subscribers. We have a really good conversion rate. And that's that kind of targeted marketing of, how recently do you visit the website or recently work with the business? How frequently are you there? And how much do you usually spend? And that's one of my favorite things to work on in data science, because it's really rewarding when you kind of predict the customer behavior in broad strokes, and then they play right into it, and you feel like a genius, and you feel like your model's a genius.
So do you feel like your sociology background transitioned really well into this data science career?
I think it can. I think the biggest way it's going to transition is when you're talking to someone who has absolutely no technical background. And you need to basically look at, we have some pretty complicated models, especially neural networks are pretty complicated. You ask senior data scientists at IBM how neural networks really work, and they're going to laugh, and they'll be like, I don't know. We don't know. I can kind of tell you how they should work, but they absolutely blow my mind every day. And being able to at least sit down with someone who has no technical background, maybe their whole background is actually just in, financial advisement or whatever it may be in the company, and say, hey, so this is what the model's telling us. Here's something similar to kind of compare it to. And this is kind of what really matters as the bottom line. I think that's where I've seen my sociology kind of work over, because it's very much about just understanding that person's needs and what they need to know, and how that's going to impact, kind of a small society, a company. And it's really been valuable to have that in the way of communicating to people, because for any of those of you who are wondering what most data scientists are saying you need going into the career field, you need to have communication. That's the biggest lacking skill in data science right now, is data scientists that can communicate well and communicate to a non-technical audience. And I think that's really where I've seen it really kind of shine and help me kind of get a leg in somewhere where maybe someone else would have had an advantage.
How much do you need to translate data to business stakeholders? Do you find that challenging? What advice would you have for that?
Yeah, so that's interesting, because it really, again, varies quite a bit on just who your business stakeholders are and how really invested they are in knowing the ins and outs of where their money's going and how it's being spent on you developing these models and generating a return of investment for them. Some business stakeholders you'll find have no interest in knowing how the sausage is made. They just want to know what it tastes like and how fast you can make more. And that's okay. That's kind of sometimes the best, because you don't want them to know exactly how you had to do things. It's pretty messy. But also it's really nice when someone actually is genuinely interested, is asking really great questions, even interested enough where you can kind of take them behind the scenes and be like, well, hey, here's the team, and here's what each of us kind of do, and I can show you how that works into the process. But truth be told, most of the time you're really going to be focusing on these conclusive findings. You're not going to be really taking a business stakeholder through your methodology of why you selected a certain model. You're not going to sit with them and say, for this time series we used a REMA X rather than just a plain REMA model. They don't care. Most of the time they don't care, and they won't want to know. They just want to know, okay, how reliably can you use the S&P index to forecast for this other fund, and are they related? And should we focus on a model that is taking in information from the S&P index fund and then deciding whether or not to buy or sell gold? And that's kind of how you can advise them on that. And that's really all they care about is it going to make money? Is it going to make money for our clients and then therefore generate more revenue for us? And so that's sometimes I think the hardest part I've seen for some people is they're so technically minded in like how this model works that they have a hard time really translating to dollar signs. And hey, this is how you're going to make money off of this. This is what you're going to save, or this is what you're going to have to spend. But in the long run, it's going to, earn you this much. And so that's really most of what your translations with stakeholders is going to be is, hey, here's what it means in monetary terms.
How much do you depend on signals from data versus statistical significance?
Significance from data versus statistical significance?
Yeah.
Gotcha. So statistical significance is going to be your best friend when it comes to running these models. These models are, we have this thing in data that measures basically the value of an actual model. And so once you've trained, let's say, a classification model, which we like to call a random forest. If you imagine a tree diagram and it's splitting down and classifying, a random forest is thousands of those. And then you're taking the aggregate and the average of a bunch of those results and picking the best tree out of, the thousands of them that you run. Or maybe a dozen, just depends on your need. And that model, you're probably going to be looking at several things. You're going to be looking at the accuracy of the model, which is how often it's just right overall with how often it's wrong. How often it's right and how often it should have been right. How often it was wrong with, something that I should have guessed right. You're going to have your recall with, how often it properly categorized something correctly. And then you're going to have its precision with how often it categorized something correctly out of the total. And all these kind of sound similar to accuracy, but I promise once you're in data science, you're going to be using these terms a lot. And within statistics, that accuracy might not always be that important because you might have a model that's overall 70% accurate. People might be like, man, that's a large clearance for making the wrong call when we're talking about something that's, looking at millions of dollars, billions of dollars maybe. But perhaps the precision is really high and the recall is kind of low. So this model precisely categorizes what we care about 95% of the time. And it's only wrong maybe 60% of the time by categorizing A as B, but it's 90% right when it's categorizing A as A. It rarely gets wrong when categorizing A as A. And so that's definitely something where the statistics come into play, and you have to kind of sit down with a client and be like, hey, look, so when I show you this model, you might have hesitations because you think it's not performing well. But the truth is you don't really care if it's accidentally labeling B as A. You just want it to label A as A. And this is what this model is really doing well. It is correctly labeled and identified A, and it does it correctly 95% of the time. And it's going to serve us well. Just if we decide we want to focus more on B, we might have to do a separate model for that. And those statistics are going to come into play to convincing kind of people. Statistics, everyone jokes that they're made up, but they're really what is super weighty and powerful when you're going before someone and when you start saying 95% confidence, or, we can confidently say that, we can reject this, hypothesis that it's going to be worth the financial investment to repair something when it's not. That stuff clicks in the brains of a lot of stakeholders because they remember science class and they remember doing hypothesis and, what it means to be confident in, your solution. And that's a way that they can kind of at least engage and understand why you're recommending something or why you're not recommending something. You can almost convince anyone with statistics if you just, present them in the right way. And so they're really going to be your kind of friend in the end.
Okay. What are some key things that you think are important to keep in mind when you're interviewing for a data science role, like a SQL rating from 0 to 5?
Sure. So in regards to interviewing for a data science role, I would say just know that there are plenty of other individuals that are smarter than you or just as smart as you that are interviewing for it as well, and that it's going to be difficult to make yourself stand out based on your intelligence alone or knowledge of the field alone. A lot of it's going to be how well you can communicate to within the interview to the interviewee. A lot of it's going to be kind of how you can perhaps communicate that you at least know what is needed to do the job for something. So such as SQL or SQL, whoever, it just really depends if anyone's taught you how to say it one way or the other. That's something that is used very highly in the industry. That's one of our greatest, highest use languages for working into a database. A lot of companies have a database that works with SQL. But the truth is that you don't need to know how to do actual, I would say, predictive modeling within SQL. There's courses that take you through it sometimes, especially an undergrad or a graduate course might be taking you through how to write a logistic model, a logistic regression model in SQL. And it can be pretty daunting, and it's not really, doesn't seem like it's built for that. And the truth is you'll never be doing it in SQL. I mean, maybe once you just find it easier to do it rather than opening up an actual notebook within Python or R and using some kind of API for that in there. But the most things with like SQL is that the businesses are looking to know, like, do you actually know what a select statement means and how to properly set up a select statement where you're filtering by a certain result needed. And if you can do that, that's usually good enough for most companies, as long as you kind of know the basics. But we're kind of at the same point for this, and I kind of want to just share it now. Every data scientist, no matter how high up they are in the company, they are opening up Google every day. They are Googling the problem that they have that they might have answered 100 times, and they're looking at Stack Exchange, and they're looking at everything else that you're looking at as a student or someone who's interested in pursuing data science. And they are learning from others, seeing how others have done it before them, seeing if it's as good as theirs or not as good. And then they're kind of taking that and they're using it to, make their model, just that much better. And I can guarantee you there are data scientists who come into work one day and they're brain dead for the day. Maybe they didn't get much sleep. They're staying up with their kids. And they're like, I don't remember how to do an aggregate window function in SQL. I know I'm supposed to. I've been doing it for 5 years. Google, how do I do a window function in SQL? And they do it and they look it up and it's okay. And that's something, that everyone does. So there's a lot of things to know about the things that we use in data science, like SQL or Python or, certain libraries or APIs. AWS is a big one. But just know that everyone in data science is also Googling it for, half the day, making sure that they're doing it right and doing the best method possible.
That was a question from Rishi. Thank you for the questions. We're going to open it up for a Q&A right now. So you guys can either type them in or raise your hand, and I'll go ahead and ask the question so that everyone can hear.
Great.
Let's see. Which cloud company do you think is going to win?
Well, again, this is, I would say, as someone who's basically just a independent contractor and enjoying not being attached to any massive company and having to kind of say what they want me to, AWS has already won. It's over. It's kind of like one of those things where, maybe you see like, two boxers in the ring and they've been going for several rounds, but you could tell one's barely hanging on. He's still doing his thing. He's still a good boxer, but this other guy's not even taking a scratch, and it's round 9. That's AWS and Oracle, AWS and Azure, AWS and, Microsoft. Like it's won it. It's owned it. It's about over COVID. I think if I remember correctly, one of the data scientists I really enjoy to follow put out an infographic about how much of the industry is actually running off of AWS now. And it's about 70%, I want to say, and the majority of like tech businesses are now using AWS. And I think it's about 50%. And when you look at like some of the Fortune 500 companies, about 50% of them are migrating to AWS for at least something, if not making the full migration over. That said, you don't have to know AWS right now to get a job in data science, but you should. I encourage you to not make my mistakes. If you're an undergrad in college, if you are very early on in your learning career of data science, get an AWS certificate. It takes 6 weeks at most to get like an entry-level one as a cloud practitioner. Do it because it's going to make you a unicorn right now. Everyone wants you to know at least a little bit, and it's going to put you a step ahead of me, put you a step ahead of a lot of my colleagues, because we're just now getting into AWS. If you can start that early, you're gonna do really well for yourself.
So you would rate AWS as a pretty important skill to have. Do you think like the Azure certifications or Google Cloud, like are those comparable right now?
Yeah. I think so. I'll say this too, just to try to be encouraging for those of you who might be pulling your hair out because you've just spent 20 hours getting an Azure certificate. That's still super useful. A lot of businesses are going to see that and immediately think, great, this person has the skills needed to at least learn one of these cloud computation platforms, and they're probably going to be way more willing to bring you on board and, you know, pay for that training to get you over on whatever they may be using, if it's not Azure or Google Cloud. But the truth is they're all pretty similar. They just have their own proprietary names. So, you know, Amazon's going to have these names like DynamoDB and S3 and Route 53, Cloud9. And you're going to see that everyone else kind of has the same thing. You know, it kind of works in the same way, especially Google Cloud. It's very similar to the way, you know, the cloud can be set up for AWS. It just has different names. And so the only thing that they don't have is how streamlined and optimized it is. You know, they're still kind of starting out. So you can definitely leverage those skills in Azure and Google Cloud. And the truth is a lot of businesses are still just barely getting into it. So you might find a position that is really great. And if you have that Azure certificate, you can kind of approach them with that. And, you know, they'll be like, oh, great. Well, we're, you know, 10% of our computing is on Azure right now. Like, great to know that you have that. And so it's still very useful. Just know that AWS will probably overtake everything in the next 10 years would be my bet. I bet we wouldn't see much of a competition in the market outside of AWS.
Okay, well, thank you so much for coming and speaking at this webinar. We've all learned so much from you. You know, great timing, you know, that you mentioned with, you know, how popular AWS is right now. QuickStart's AWS certification prep course is actually on sale now, as well as our data science boot camps. So as Shane mentioned before, master's degrees, PhDs aren't really what you need to get jobs in data science. So our boot camps and certification prep courses will really prepare aspiring data scientists.
Yeah, again, I want to encourage everyone, do that AWS certificate. Definitely, you know that you don't have to go $50,000 into debt getting a degree or a higher, you know, graduate degree. You can get started today, do a boot camp just like I did. You can switch your career if you're kind of have any hesitation about it. You can do it. You know, many of us are doing it right now.